Right, so today we're going to talk about the last method for solving quadratic equations. Talked about graphing method where we're looking to see where the parabola crosses the x-axis. We talked about the square root method, which we're only going to use when there's not a b in the equation. And the quadratic formula, which needs to be a last resort. Unfortunately, it may not be the case for some of you, but that's okay. So now we're going to talk about the last method, which is called factoring. We're going to do that in just a second. So we should be able to solve quadratic equations by factoring. So that's it, right? So Morpheus says, what if I told you you could use factoring to solve quadratic equations? In other words, instead of using the quadratic formula, where we have to remember what the formula is, plug in numbers, do a bunch of arithmetic, possibly make a bunch of mistakes because there are so many steps to it. If you can factor, then your life gets much, much easier. You have to be able to factor. The background of the factoring method, right, the reason why it works is because of something called the zero product property. The zero product property says that if you're going to multiply two things together and they equal zero, so if you're going to multiply two things together to equal zero, one of them has to be zero, right? And so you see here 3 plus 0 is 0, 3 times 0 is 0, 0 times 5 is 0, 0 times 0 is 0. So it doesn't matter which one of the two things is 0, as long as at least one of them is, then when you multiply them, they will give you 0. Okay? Now, being able to apply that to a situation where you have quadratic equations, it always seems to be a little bit of a hiccup for people. So I think looking at this might make more sense. So if we're going to multiply two things, call them A and B. So if A times B is going to be equal to 0, if I'm going to multiply A and B together and get 0, that means that A has to be equal to 0 or B has to be equal to 0. It doesn't matter which one. And so keeping that in mind, and keeping in mind that normally we're looking for two solutions to a quadratic equation. That's where your two solutions are going to come from. Taking one of the factors and setting it equal to 0, and taking the other factor and setting it equal to 0 to find out when they'll be 0. It's all about these factors being equal to 0. Okay? That's the sort of basis behind solving by factoring. Okay, so let's just get into it. Here's a quadratic equation, x squared minus 4x equals 45. You cannot use the square root method, and what I meant before is by not having a b, right? B is always the coefficient on the x to the first term, and in standard form, and so there it is. Negative 4 is your b. So you cannot use the square root method. Instead, we can use the quadratic formula, but what if I told you there was an easier way to do that? Okay, we still have to get this equation in standard form. We still have to get it equal to 0. We still have to see where the 0 was put in for the y. Remember that what we're basically doing is finding x-intercepts. X-intercepts are on the x-axis, and if you're going to be on the x-axis, the y-coordinate has to be 0. So we're basically plugging 0 in for y and solving an equation. So we have to subtract 45 from both sides to get this thing equal to 0. Now we're in standard form. Now I can see the A, B, and C. And yes, we can use the quadratic formula, but watch this. Let's try to factor this trinomial instead and see what happens, right? So we always look for a greatest common factor first, and there's not one here. So from this trinomial, we know that it should factor down into two binomials. We know that because we spent about a month and a half doing this, right? So let's see. Factor down the first term into x and x. That goes here. Then we can always do our little table. We've got to factor down A and factor down C. So A is 1 and 1. Factors for negative 45 could be a bunch, right? So negative 45 and 1, 45 and negative 1, negative 9 and 5, 9 and negative 5. Okay? Now, the trick is, remember that we need combinations of the factors of A and the factors of c that will multiply and then add together to give you b, which is -4. Okay? Now, the factors of a are just 1 and 1. So we can multiply 1 times 1 into all of the factors for c if we want, but they're not going to change the factors for c. So we're basically looking for the factors of c that will add to -4. And we see that -9 plus 5 are exactly those two factors. So we put -9 here and a +5 here. It doesn't matter because they're both going to get multiplied by 1x. Okay, so there we factored. If we were to FOIL x minus 9 and x plus 5, we would get x squared minus 4x minus 45. Okay? Now, remember that factors are two things that you multiply together to get you back to the original whatever, the original trinomial. So these two factors are being multiplied. And so what this equation is saying is that this factor times this factor must equal 0. So the zero product property says, well, if that's the case, then one of those factors has to be 0. So when will this factor be 0? Or when will this factor be 0? Because we don't care which one is going to be 0 as long as one of them is. Well, to find out when those factors are going to be 0, we can set them equal to 0 and solve for x. So we do that. We add 9. X is 9 here. Subtract 5, x is -5 here. So if I were to take 9 and plug it in for x, here and here, we would get 0 here and 14 here. And 0 times 14 is 0. So that will work for this equation. That's a solution for this equation. Right? At the same time, if we put -5 into here and here, then this would be -14, and this would be 0, and -14 times 0 is also 0. So not only will 9 work, but -5 will work. These are the two solutions for our quadratic equation. So you factor down and set your factors equal to 0. That's what will tell us how to get that product to come out to 0. Okay, and those are your solutions. If we were to graph this function, the parabola would cross the x-axis at 9 and -5. Okay, you have to keep in mind all the different things that we're finding here when we solve a quadratic equation. Okay? All right, a little quicker now. So, number 2, we look at this. We cannot use the square root method because there is a b. So we are going to get this in standard form by subtracting 11x. We get 2x squared minus 11x plus 12 equals 0. And so now, yes, we can use the quadratic formula, but that's long and tough, and you have to remember the formula and all that kind of stuff. So let's try to factor. There's no greatest common factor besides 1. So we go right into our parentheses. Factor down the first term, 2x squared, into 2x and x. Now we do our tables. I need to factor down a and factor down c. A only factors into 2 and 1. C can go 12 and 1, -12 and -1. -4 and 3. 4 and -3, or -6 and 2, or 6 and -2. So a lot of different possibilities there. And remember that our game now is to take the factors of A, multiply them by the factors of C, and try to add those guys to get to -11. So we need combinations of those factors that will add to -11. You can go through and check all of these combinations that you want. What you will find out is that 2 and 1 and -4 and 3 are how this is going to work. If we take 2 times -4, we get -8. Back up. Oh, wait. All right, -4 and -3 would be your factors for positive 12, right? They both got to be positive or both got to be negative. It would be the same thing down here. So Little mistake there. But anyway, it doesn't change the fact that we're going to use 2 and 1 and negative 4 and negative 3. Because 2 times negative 4 is negative 8. 1 times negative 3 is negative 3. You add negative 8 and negative 3, and you get negative 11. So we use our smiles to link our factors, right? Since we're multiplying the 2 times negative 4, then we got to put a minus 4 here at the opposite end of the smiles. And since we're multiplying the 1x times negative 3, those guys get linked by the other smile. So they are your factors. If we multiply those two factors, we're supposed to get 0. That means that either factor needs to be 0. We don't care which one. So we set these factors equal to 0. And we solve for x to find out what we can put in for x to make each of these factors 0. So you add 3, divide by 2, you get 3 halves. And you add 4 over here, you get x is 4. And those are your two solutions. Okay? Those x values, if you were to plug them into the equation, would make that equation true. So they're your solutions. Those are your x-intercepts, your roots, your zeros, however you want to look at it. Okay? And that's it. That's all there is to it. Okay? Another one here before I turn you loose on your own. Right? So, same thing. We're in standard form. We cannot use the square root method because there is a b. And so, yes, we can use the quadratic formula, but let's factor. Greatest common factor. You can factor out of 4. Get 2y squared minus 7y minus 15 equals 0. And then we've gone through the factoring process twice now. Hopefully that's enough for factoring down a trinomial to jog your memory. You've got to just be good enough to factor to get down to using these as your factors for 2y squared minus 7y minus 15. If you cannot factor, then you're going to have to get in here and get some help. Okay? So those are your factors. Now, it doesn't matter how many things you're going to multiply together. If you have 3 factors or 4 factors or 5 factors, and those factors are going to have to be multiplied together to get you 0, then one of those factors has to be 0. We don't care which one, so we go find out how to make each of them 0. And the way we find that out is we take each factor and we set them equal to 0. Right? Now, the problem is, well, not the problem, but the first thing that we see here is that 4 equals 0. Well, do you get a solution out of that? No, 4 does not equal 0, so that's not going to give us a solution. So we solve this guy. Subtract 3 divided by 2, and y is negative 3 halves. Add 5, and y is 5. And there are our two solutions. Okay? So factor out a GCF. Sometimes the GCF will help us get to a solution, but not all the time. Okay? We may come across one that will allow the third factor to give us a solution. And so we'll talk more about that when it happens. Okay? All right. Number 4. So same thing, right? This has got to be in standard form. We've got to be equal to 0. The equation has to be equal to 0. You've got to see where that 0 was plugged in for the y. Okay? Now we see that we have a b, so no square root method. And so let's factor. And we can factor out of 3 as a greatest common factor. And then you have to get good enough at factoring to know that this guy factors into x minus 5 and x plus 1. Okay, so there are factors. To find our solutions, we're going to take each factor and set them equal to 0. The zero product property tells us that we can do this. This is not going to give us a solution because 0 does not equal 3. And there's no x to solve for in there, right? So here we add 5, subtract 1, And so our two solutions, x plus 5 and x minus 1. That's a minus 1 in there, right? And it's that simple. Okay? All right. The only way that we can actually complicate this is to make you do more work to put your equation in standard form, like number 5. Okay? It's not a big deal. We still have to get this in standard form. We still have to move everything over to one side. We still have to be able to see that 0 to know where the 0 was plugged in for your y. No problem. I'm going to subtract x squared. I'm going to subtract 3x. And I'm going to subtract 20, all at the same time. And you can do them one step at a time if you'd like. But we do that, and this entire side turns into 0. And then we combine our like terms. 4x squared minus x squared is 3x squared. 2x and negative 3x is negative x minus 24. And now we're ready to start factoring. Greatest common factor, there's not one. We can't use the square root method because there's a b. And so we factor. Okay. Excuse me. So let's see. What are we doing here? Well, maybe writing this out is a little bit easier. So 3 and negative 24, we need factors of 3. And then factors of negative 24, there's going to be a ton of them. Oh boy. All right, that's okay. This is the way it goes. So there's a bunch of them. Now we need combinations of those factors that will add to negative 1. And now that I've written them out, I couldn't come up with them in my head. Now that I've written them out, I see that if I take 3 and 1 and 8 and negative 3, then I would get negative 1 if I took negative 3 times 3 and 1 times 8. Because negative 3 times 3 is negative 9. And 8 times 1 is 8. So negative 9 and 8 will add to give us negative 1. So now we link our smiles. So we're supposed to multiply the 3x times negative 3. We're supposed to multiply the 1x times 8. So there are our factors. Now, our zero product property says that one of these factors has to be equal to 0. So we set them equal to 0 and go solve. Subtract 8, divide by 3. Should get us negative 8/3 and 3 as our two solutions. Okay, so not a lot more complicated. Just, again, make sure that the equation is equal to 0. And then factor and set your factors equal to 0. Okay? Nice little comic here to break up the monotony. So you see that complicated equation up there, and kid raises his hand and says, wouldn't it be more efficient to just find who's complicating equations and ask them to stop? Okay, good math humor right there. All right, moving forward. Number 6, again, we've got to work to get this guy in standard form. And then go to work, factor and all that kind of stuff. So we're going to distribute the x here, get 2x squared minus x equals 15. Then we're going to subtract 15 from both sides so that we can see this equal to 0. We can see where the 0 was plugged in for y. And we can't use the square root method because there's going to be a b. So we go right into factoring. We need factors of negative, let's see. So we got to play our game. Let's see, we can go, minus 3 here plus 5 here. Negative 3 times 5 is negative 15. And then when you do your smiles, you get negative 6 and positive 5x. Negative 6x and positive 5x, which is negative x. So that's what our factors are. We set our factors equal to 0 to find out how to make them 0. And we see that 3 and negative 5/3 are our two solutions. Okay? It can be pretty easy. All right. Try 7. You're going to have to do some simplifying first. Try 7 on your own. Stop the video. And then when you have it, start it back up and see if you're right. Okay, you should have gotten this, right? Distribute the 2. And then subtract 2x squared from both sides. And you should end up with 3x squared plus 10x plus 8 equals 0. And then you should have factored that guy down into 3x plus 4 and x plus 2. Set your factors equal to 0, and you get negative 2 and negative 4/3. Okay? If you can't see what happened here, come on in during STAR and we'll take a look at it. Okay? Some more for you to, well, number 8's a little bit weird, so let's talk about that. Number 8 looks like it's already factored. And so to take what's already factored and to FOIL it out seems kind of strange. But the problem is this is equal to negative 3. So it's not in standard form. If that were equal to 0, then we would already have our 2 factors and it'd be equal to 0, and we would just set the factors equal to 0. Unfortunately, it's not. So we are going to have to work backwards in order to go forwards. So let's go ahead and FOIL. So double distribute the 2x. And the negative 1. And then we're going to combine those like terms, and I'm going to go ahead and add 3 at the same time. Okay, just for time purposes. So that's our quadratic equation in standard form. So now we go factor. And it factors into 2x plus 1 and x plus 1. And then we set our factors equal to 0. Get negative 1 and negative 1/2. And there are our 2 solutions. If we were to graph that quadratic function, it would cross the x-axis at negative 1 and negative 1/2. Okay? Last but not least, number 9. Okay, again, we're factored. Well, take a look at this. Can we use the square root method? Look at this. Can we use the square root method? Yeah, we actually can, right? There's not a b, right? I mean, it's actually, this is more in vertex form, where this would be h. And then if we subtracted the 18, we would have a k. So since this equation is more in vertex form, we can actually use the square root method. And that's the method that we should use, right? So we're going to kind of throw this in on you just to trick you up a little bit and see if you're paying attention. So we're going to divide by the 2 and then square root, get x plus 3 equals plus or minus 3. Then we're going to subtract 3 from both sides. And so we're going to get negative 3 plus 3 when we go upstairs. Well, let's just write it out. So negative 3 plus or minus 3. Then our 2 solutions come from going upstairs, negative 3 plus 3, and going downstairs, negative 3 minus 3. So you get 0 and negative 6. So if you're already in a position where you can use the square root method, just use that instead of trying to go through some other method. Okay? All right, that's it. Homework's out in Canvas. Go ahead and get that knocked out by next time.